so large. Supermicro was here, of course, showing off their chassis, whether it's GPU compute dense or CPU compute dense or blade centers or whatever you're looking for, they're building a chassis for it. Even the new E3.S, yes, the new form factor. I mean, theoretically, that's the form factor would support up to PCIe Gen 6, but they're already showing off PCIe Gen 5 qualified platforms. This is the X13-8U with 8 max 1550 Intel GPUs. So 128 gigs of HBM3. That's a lot of horsepower. That's a lot of GPU horsepower in one package. So that's, you know, this is Intel's packaging technology come to the GPU, kind of a little bit, I mean, not really ahead of the CPU, but parallel to what they're doing with CPUs. So this chassis design for the E3.S, you've got 32 slots, but you've got two PCI Express 5 lanes to each device. So no bandwidth limits there, and that's just 64 lanes directly to the CPU. But you've actually got 2 rows of devices for a total of 128 lanes in the device. So this is a CXL module, and you know, most people don't realize, but the E3.S standard is rated, or the design spec has up to 16 PCIe lanes as part of it. But right out the gate, we're going to have CXL and up to 8 lane devices. It's a lot of bandwidth in a very small package. So the E1 modules are more designed for a 1U rack configuration, whereas this is a 2U server. You know, we've got all the connectivity. This would be really good. You could still use this for 1U configurations. That makes sense if you're going for density, clusters, maybe you've got a 4-node system in 2U. The E1.S format is going to make a lot more sense in that scenario. Supermicro is also showing off their liquid-cooled AI development platform. There's a distribution block inside a relatively normal-looking tower/rack convertible chassis. You know, your normal looking NVMe storage at the front, and then everything is all about airflow. And everything's all about airflow to the distribution block and the radiator, and then your liquid cooling for all of your AI compute that lives inside. Supermicro was also showing off the Bluefield DPU3, you know, NVIDIA innovation. NVIDIA basically needs everybody to make all of their systems. They can't make systems fast enough. And the interconnectivity and moving the compute required for network connectivity for 400 gigabit off of the CPU and off of whatever the GPU infrastructure might be and onto the DPU is making a lot of sense for these AI systems. And so the network cards have suddenly gotten very complicated, basically turned it into their own standalone systems that then talk to their host systems via PCIe. So you can do a lot of compute directly on that PCIe card and take a lot of the burden off of the host system. In case you're having trouble picturing what 4 GPUs might look like when it's actually mounted inside the system, this will give you a little bit of an idea. We've got our NVIDIA GPU here, and even though this is a desktop case, because these GPUs don't have their own cooling, the air pressure from Supermicro's, I mean, look at these fans. These fans move an enormous amount of air. This type of a GPU in this kind of a tower, because of the airflow, it will be sufficient cooling for these 2-slot GPUs that don't have their own active cooling like a normal GPU would. This is an AI compute H100 type GPU, so this is what's necessary to keep them cool, but also not super loud. The first board I took a look at Tyan's booth, of course, is the AM5 board. PCIe layout here is very, very smart. We haven't really seen this from any of the server-based AM5. They say they're ready to go for the higher TDP, but you're going to need liquid cooling, so you're going to have to sort of keep that in mind as you think about a chassis for this board. But 4 DIMMs, standard ATX power for like the home lab, home server type deploy, this could be a really good solution. To get 2 Gen 4 M.2, one right on top of the other, and you've still got all this PCIe connectivity. This is really good for the AM5 platform, considering that you've got, you know, relatively limited PCIe lanes coming out of that, and it's got the onboard IPMI. You get a pretty good rear I/O configuration in terms of onboard capabilities, including that dedicated IPMI port, video, and VGA from your IPMI. Plus, you've got all that PCIe connectivity. If you want something that's a little bit more suitable for desk-side computing, there's also this dual-socket configuration for Sapphire Rapids. It's still designed for flow-through cooling like you would have on a rack mount server, but this can also work in a workstation configuration. Again, you run 2 dual slot GPUs in these slots, and then you have these 2 slots for your high-speed peripherals or whatever that you might need to run in a workstation. DPUs, X16 peripherals, PCIe Gen 5. If 2 sockets is overkill for your application, there's the Tempest HX, the S5652. This is a single socket version of much the same. You get a little bit more room for more PCIe slots, and again, it's meant for the dual slot GPU configuration, plus you've still got some PCIe slots for whatever you want to run. You could run up to 4 dual slot GPUs with this config. That would be no problem. For some of the other home lab, like advanced home lab or embedded solutions, there's also the LGA 1700 solutions, because don't forget, with the i7, you can run error correcting memory. So they have the SODIMM based solution here that has integrated NICs, and then they've got a more desktop-ish class micro ATX motherboard platform, which also has pretty solid built-in audio. They've also got the Tomcat CX8056 if you want to do 2 DIMMs per channel. This also gives you an OCP3 slot. You've got onboard IPMI, as you would expect. You've got the expansion slot risers here. And this motherboard also offers a lot of PCIe connectivity at the front edge of the motherboard. So this chassis is the chassis that will accept either motherboard, the S8056 or the Intel version. Both will physically fit. You got the OCP3 slot at the back. So if you want to see the S8056 in a more chassis configuration, that's what it would look like in 1U. So in this configuration, it makes a little bit more sense. You've got your OCP3, you got your PCIe risers here at the rear, you got your dual 2 DIMM per channel configuration for Genoa. That was not something we saw on launch, but it's now qualified and in the channel and basically ready to go. And then all of that PCIe connectivity that we saw at the front, all of that comes here to 12 NVMe bays. This chassis, the genius of the board design is that it's exactly the same layout for the other model motherboard. You just swap it out and you could run this in a dual CPU configuration. They're cloud platforms. You got the Genoa socket, 12 memory channels, although you can run more than 12 DIMMs for capacity if you really need it. But 12 DIMMs is recommended. You got your OCP3 slot at the front. And then this is a variation of this is IPMI. Is this an IPMI interface?
IPMI, yes.
This is a variation on the IPMI interface that I have not seen in the wild. Having aftermarket and add-in IPMI is just another layer of security assurance when building the system, because you can have separate quality control, separate production lines, and separate assurance that nobody's putting anything in there that they shouldn't be putting in there. So, and there's 4 of these nodes in this 2U chassis. So you could have 96 times 4 CPU cores total capacity, 4 independent systems, and you've still got enough physical room to run those 15 terabyte E1.S NVMe that we saw earlier. This is the Tyan Transport TN85B8 261, the Transport SX. As configured, you've got 24 NVMe bays at the front, and they are using retimers in order to drive all of that PCIe connectivity back to the front. But with this dual socket Genoa system, you've still got enough PCIe lanes that you've got 2 X16 slots at the rear that are open for high-speed networking or DPUs or any other kind of high-speed I/O that you want to run. If you don't need 24 NVMe at the front, you can eliminate the risers and actually pack 4 GPUs at the rear on this chassis. So it's a very, very flexible chassis depending on what your needs are. If a 2U configuration is a little bit more your speed, the motherboards we've already looked at are available in 2U configurations. This is the Transport TS70B8056. These are 3.5-inch drives at the front. You've got a combination of NVMe and 3.5-inch SATA, and all of your PCIe connectivity is still available at the rear. So you could run full height, full length GPU configurations in this, and you've also got 2 DIMMs per channel, single socket motherboard in this configuration. Or you can use retimers. Now that motherboard has a bunch of connectors which will give you 18 of your NVMe at the front. The extra NVMe come from retimer cards, but you still got a lot of PCIe connectivity at the back in this version of the chassis. This is the TS70AB8056. You can see all that NVMe at the front. You may have heard of the Open Compute project or the Open Compute standard. This is the Capri 2 OCP server. So Open Compute is its own universe of awesome things, but each one of these is a compute node that's designed to be installed in the Capri 2 chassis, but they're different configurations. So this configuration gives you 2 half-height, half-length PCIe slots plus 2 standard U.2, and you've still got an OCP3 slot down here. We've got some sort of 25 gigabit Ethernet interface.
Yeah, depends on the purpose that you can have the different
4x25, 2x100, 2x400, just whatever kind of OCP3 peripheral you need. You've got your Genoa slot, you have 4 DIMM slots, so it's 4 channels. And this configuration brings you all of your PCIe connectivity to your slots at the rear, but you've got 4 E1.S slots, so you can run 4 NVMe in here in whatever kind of disk configuration you want. And so this chassis has 1 full-height full-length slot and 1 full-height half-length slot. But this will work for AI accelerators and you know, inference cards, basically anything you want to throw at it. And it's full Gen 5. In case you think that AMD is getting all the Open Compute action, no, the Open Compute modules are also available in Sapphire Rapids configurations, and that's what they had up and running on the show floor. That you can actually take for a little bit of a spin in this configuration.